Today, we're going to look at how some really brilliant new methods are just smashing through major bottlenecks in research and manufacturing. We're talking about finding smarter, faster, and you guessed it, stronger ways to solve some of the toughest technical challenges out there. All right, let's get into it. So let's just start with a huge question. How do you solve a problem that feels, well, impossible? Some challenges are so tough that just throwing more money or more effort at them, it just doesn't work. You need to come at it from a completely different angle. And really, it all boils down to two basic approaches. On one side, you've got brute force. It's slow, it's super expensive, and honestly, you usually only get these tiny incremental improvements. But on the other side, you have ingenuity, and that's where it gets exciting. It's fast, it's clever, and it can lead to massive, game-changing breakthroughs. Today, we're digging into two awesome stories of ingenuity. Okay, so our first story kicks off with a major bottleneck in the world of industrial research. The crazy amount of time and money it takes to run physical experiments just to figure out the best way to make something. Now, for decades, one of the smartest ways around this has been something called the Taguchi method. It's basically a statistical tool that helps you get the data you need with way fewer experiments. You can think of it like a cheat sheet for finding the best results without having to test every single possible combination. It's a really clever system, but it's still held back by the fact that you have to run those physical tests. And that, of course, leads to a really interesting question. What if you could push this idea even further? What if you could get those same amazing results, but with even fewer physical experiments, saving even more time, even more money? Well, that's exactly the challenge a team from the University of Baghdad decided to take on. And their solution is so clever. Instead of getting bogged down running more and more tests in the lab, they just decided to predict the results of the missing ones using artificial intelligence. Okay, so here's the four-step playbook. First, they ran just a handful of the most essential physical experiments. Then, to fill in the gaps, they used statistical methods to predict what would have happened in all the experiments they skipped. Now, with this bigger data set, a mix of real and predicted results, they trained an AI, an artificial neural network, to understand the whole system. And then for the final step, they just asked the AI to figure out the absolute best settings. And it worked with incredible accuracy. So, did it actually work? Oh yeah. This quote from their paper says it all. The predictions made by their AI weren't just a little better, they were closer to the actual results they would have gotten if they had done all those expensive, time-consuming experiments for real. They basically used AI to create a massive shortcut through a huge research bottleneck. All right, for our second story, we're going to switch gears completely. We're moving from a problem of data and computation to a really physical one, a material that's incredibly important, but is almost impossible to work with. I want you to meet silicon carbide, or SiC. On the Mohs hardness scale, it's a 9.3. That's nearly as hard as a diamond. I mean, think about that. This incredible toughness is exactly what makes it perfect for the high-power electronics that run everything from electric cars to 5G networks. But that exact same superpower makes it an absolute nightmare to manufacture. And the main bottleneck is polishing. Getting a silicon carbide wafer perfectly smooth is non-negotiable, but it is an unbelievably slow and difficult process. This analogy just nails it. Trying to polish SiC with the usual methods is literally like trying to sand a diamond with a paper napkin. It's not going to work. So how in the world do you solve a problem like that? Well, researchers at Taiwan's Industrial Technology Research Institute came up with a brilliant idea. They decided to tackle this impossible physical challenge with light. I know this looks like something out of science fiction, but this is their actual lab setup. They're using what's called a femtosecond laser. It fires these unbelievably short pulses of light, and they're aiming it right at the silicon carbide. But the truly ingenious part here isn't that they're using a laser, it's how they're using it. And here is the big twist. You'd think they'd use this super powerful laser to just blast away or cut the material, right? I mean, that's the brute force approach. But no, they're using it to fundamentally change the surface of the material, to actually make it softer. And the result is pretty wild. Check this out. This is a microscopic view of the silic surface after the laser hits it. It creates this porous, textured layer they call a modification layer. And this new top layer is chemically different. And this is the crucial part. It's way, way softer than the original silicon carbide underneath it. The data doesn't lie. This graph shows you just how much softer it gets. See the curves way over on the left? That's the original, incredibly hard surface. But look at what happens after the laser treatment. The hardness just plummets. They've effectively turned a diamond-like surface into something you can actually work with. So, okay, they made the surface softer. That's cool. But what does that actually mean for that polishing bottleneck we were talking about? Well, the results were absolutely incredible. For one side of the silicon carbide wafer, the polishing speed, what scientists call the material removal rate, improved by 77%. I mean, right there, that's a huge win. But get ready for this. For the other side of the wafer, the improvement was a mind-blowing 207%. That is more than 3 times faster than the old method. They didn't just speed things up, they totally transformed the entire process. This chart just lays it all out so clearly. The 2 short bars on the left of each pair, that's the old slow polishing rate. Now look at the tall bars on the right, the ones for the laser-treated samples. The jump is it's enormous. By making the material softer first, they made polishing it unbelievably efficient. So when you put these 2 stories together, one about AI and data, the other about lasers and super hard materials, what does it tell us about the future of how we make things? Well, here are the big takeaways. First, AI can work like a virtual lab, predicting outcomes to save a ton of time and money in research. Second, high-tech tools like lasers can do more than just cut things. They can literally re-engineer the properties of impossible materials. But the most important takeaway from both is this. The smartest solution isn't about using more brute force. It's about finding a completely different, more ingenious approach. And that kind of leaves you with one final thought. It makes you wonder, doesn't it? What other impossible challenges out there right now are just waiting for one clever idea, one little shift in perspective to be solved?